So Mia, 19, 20, and 21. I did 19 and 20 for you. 21, you need to come see me because that involves a longer explanation. But 19 and 20, they've given you an and an or statement there. When they give you an and statement like 19, just take each of the inequalities and work them out separately. So I took the 5z greater than or equal to -10, and I just divided by 5 on both sides. And I get z is greater than or equal to -2. So you can see I've graphed that on my number line. And then for the second equation or inequality, it's 3z less than 3. So to isolate z, I divided by 3 on both sides, and I get z is less than 1. And so you can see that I've graphed that in blue. Now, because this is an and statement, this is important. You only want the overlap of the two graphs. In other words, any value of z that I include in my final answer has to be included in both the red graph and the blue graph. So the red graph, the lowest value is -2, and then the blue graph, the highest value is +1. So I can only report numbers between -2 and +1 because it's an and. It has to be on both graphs. And so it's where the red and the blue are overlapping there. And if we look at number 20, you can see that this is an or statement, not an and statement. So an or statement means that if the numbers are in either of the shaded regions, we count them. So I took the 5p greater than or equal to 10, and I divided by 5 on both sides, and I get p can be greater than or equal to 2. So that's what I've graphed in green. And then the second equation or inequality was -2p less than 10. Now I divide by -2 there, and the rule is when you divide by a negative, you have to flip the inequality. So I flipped it, and I get p is greater than -5. So you can see in pink I've graphed the p is greater than -5. Now again, because this is an or, it means if you're in the green or in the pink, that you count as part of the solution. And since the green is all contained in the pink, I only use the pink because the pink, again, it contains the green. So if you're in the green or the pink, you're part of the solution, but all of the green is in the pink. So when I graphed the black one, my final one, I just graphed the pink because that included everything. So I hope that helps. Come see me tomorrow, okay? So Mia, here's number 27 that you asked about. It's an absolute value problem. So you have to work out two cases, because absolute value is your distance from 0 on the number line. So for instance, if I told you that the absolute value of x was equal to 5, that means x could either be 5, because 5 is 5 units from 0, or x could be -5, because -5 is also 5 units from 0 on the number line. So what you have to do there is you have to take what the expression that's inside your double lines, your absolute value, in this case that's 2x plus 5, and you have to set it equal to 3x plus 4. In other words, the first case will always just be dropping those lines and working the problem as you normally would. So I'm going to subtract 3x on both sides, and when I do that, I'm going to get -x plus 5 is equal to 4. I'm going to subtract 5 on both sides, and I'm going to get -x is equal to -1, but that means if I divide by -1 there, that x is actually equal to +1. Now for the second case, you drop the double lines, and this, what's on the right side, that's actually going to get multiplied by -1. In other words, we're considering that opposite possibility. Just like with the 5, it was 5 or -5 that could be the answer. So I'm going to take the 2x plus 5, and I'm going to set it equal to -3 minus 4. So I'm going to add, hold on, let me get the right color there. I'm going to add 3x to both sides. And after I add the 3x, I am gonna subtract 5 from both sides. So I've got 5x plus 5 is equal to -4, and then I'm gonna subtract 5 on both sides. So I'm just doing the algebra now. 5x is equal to -9, and if I divide by 5, then I get x is -9/5. So you just have to be aware when you see those double lines. If you see two lines, you're gonna have two scenarios you have to work through. The first one, you just drop the double lines and work the problem. The second one, you have to remember to flip the sign on what comes to the right of the equal sign, the part that's not in the double lines. So take the opposite of it as you would, just like with the 5 and the -5 there. So Mia, this next one asks you to solve for m. So if I look at m right here, I'm not going to move m. I'm going to get rid of the things that are on the same side of the equal sign as m, which would be the p and the v. Which one do I get rid of first? I'm always going to do the addition or subtraction first. So since it's a plus p, I'm going to subtract p on both sides of the equal sign. And so on the left side, I'm just going to write it as a minus p because I can't combine those. I'm going to bring down my equal sign. I'm going to bring down my v times m, and I'm going to cancel the plus p and the minus p. And now again, I'm trying to solve for m. So on the side where m is, I still have a coefficient of v. That's multiplication, and division will undo that. So I'm going to divide by v on both sides. So my final answer then would be a minus p divided by v is equal to m.